तो हाय। तो आज जो हम क्वेश्चन डिस्कस करने जा रहे हैं दैट इज द थर्ड क्वेश्चन फ्रॉम द Amazon series, find duplicates. So what is given in the question? We are given an array of size n plus 1. We are given an array of size n plus 1. Okay, and what we have to do, and the elements in the array are from 1 to n. Okay, and we have to find one number that repeats in the array. In the array that has its size n plus 1, accommodate elements from 1 to n. So there might be one element or more than one element that are repeating in this. Okay, and we have to find it in linear time complexity, that is in the time complexity order of n, and the space complexity less than order of n. That means we have to find it in constant time. So how do we approach this question? Let us see that. So let us assume a test case that is given in the question. 3, 4, 1, 4. As we can see, it has two repeating elements between, because it has size 5. It has size 5, so it have two repeating element. So what we can do, we can maintain a hash table of size n, that is the size of the array. We can maintain a hash table of size, let's suppose in this case of size 5, so the indexing will be from 0 to 4. Now for every element we iterate over the given array, we'll store the frequency of each and every element in this hash table. So for 3 it would be 1, for 2 it would be 0, for 1 it would be 2, for 4 it would be 2. Easy. And while iterating over the array, over this hash table, from here to the last element, we'll check if the frequency of a particular element, your frequency of a particular element is more than 1, we can return the index of that particular element. That is, we can return 1, because we have here we have two repeating elements, we can return either of them. Okay, so we can return 1. Now what is the point of this question? Because it seems to be a very easy question, but we have done it in the time complexity of order of a linear time complexity that is required in the question, but we are also using an extra space that is order of n. So is not correct. This is not correct. So how do we solve this question in space complexity of constant space complexity? So to solve this question, we must you must have the knowledge of Floyd cycle detection algorithm. Cycle detection algorithm that is used in linked list. Okay, so basically what this algorithm states, let's suppose we have an element 3, 1, 2, 4, and this is a cycle. So to detect a cycle, we in a linked list we use this algorithm. So what we do in this algorithm, we take two pointers, that is one slow pointer and one fast pointer, and both of them starts at the starting of the linked list. Initially both are at the starting of the linked list, the head. Okay, and what is the significance of the slow and the fast pointer? The slow moves one step at a time, the fast move two step at a time, and when the slow and the fast pointer meet, if the slow and the fast pointer meet, that means there is a cycle in the algorithm. If slow and fast pointer meet, there is cycle in the linked list, otherwise there is no cycle. Okay, so let me do a dry run over this. and then we jump to how this method relate to this question. Okay, so we have a slow and a fast pointer initially at the head of the linked list. Slow will move one step, fast will move two step. Slow move one step, so it will come here. Fast move two step, so one step it would come here, and the two step it would be at the same position. So here slow and the fast pointer meet. That means there is a cycle in the linked list. Okay, now how can this approach be related to our question? So let me show you. So what we are given the array 3 4 1 and 4 1. Okay, let us draw the linked list representation of this array. So what is the linked list representation of this array? Starting from the first index, we assume the value that is stored in the first index as the first node. Okay, this as the first node. Now the value that is present at the zeroth index will act as in the next index, that is this one. We link this to this. Okay, this as this value act as an index of the next node. Okay, so there is a link between 4 and 3. Now this value act as an index to the next node. So 4 is here, act as an index to the next node. Now from here 1 will be act as an index of the next node. So it will be pointing to 4. This would be pointing to 4. Okay, now this 4 will act as an index to next node. So we have here 1. So that means there is a cycle here. Okay, this is the linked list representation of this array. Let me do one more dry run on another case. Let's suppose we have 1 2 3 4 and 1. Okay, we have this. So zeroth index 1 2 3 4. Starting from the zeroth index, it is our first node. This now will act as an index of the next node. So this will be our next node. This will act as an index of the next node. So this will be our next node. This will be act as an index of the next node. So this will be the next node. This 4 will act as an index of the next node. So here it would be 1. Okay. Now. 1 will be as an index. 1 would be act as an index of the next node. So at 1 we have 2. Draw this. Okay, when there is a repetition, let's suppose we are traversing the array. When we return to the same array element second time, we form a loop. Okay, because at this one we do the same thing. When we reach the index the second time, we form a loop. Okay, now cycle, sorry, we form a cycle. Now we have formed the linked list representation of this array. Now what we apply the same cycle detection Floyd cycle detection algorithm to find the cycle in this linked list representation. So how would we do it, and what is the significance? Because if there is cycle present in this, that means there is one repeating element that would be present. Okay, because due to which the cycle would be present in the linked list representation. Okay, so we'll have the slow and the fast pointer pointing to the head of the linked list. Slow will move one step at a time, fast will move two steps at a time. Slow will move one step at a time, fast will move two steps at a time. That means fast and slow meet at a point. That means the cycle is present in the linked list. That further means that there is a duplicate element present in the array. Now we have confirmed that there is a duplicate element that is present in the in the array. Now what we'll do, we'll left one of the pointer to the intersection point of the slow and the fast pointer and make the second pointer point to the head of the linked list representation of the array. Okay, and now we'll move fast and slow one step until their value becomes the same. So initially the fast is at value 3 and slow is at value 1. We'll make is the value pointed by the both pointers are same? No, they are not. We'll make fast move by one step. We make slow move by one step. Is the value presented both pointers are same? Yes, they are. So we'll return 4, the value. Because there are two repeating elements now, we can return any of them. Now for this case, let us analyze this case. We have a slow and a fast pointer at the starting. Here, we'll make the slow pointer moves one step at a time, makes fast pointer moves two step at a time, make slow pointer move one step at a time, make fast pointer moves two step at a time, make slow pointer move one step at a time, make fast pointer moves two steps. So after taking one step, it would be here, and after taking two steps, it would be here. Okay. Now we'll move the slow one step. We'll make the fast moves two step. So fast and the slow meet at a point. That means there is cycle in the linked list. That further means there is a repeating element in the array. Now, now what? We'll make one of the pointer points to the head of this linked list representation. We'll make one of the pointer here, point to here, and we left one of the pointer. Let's suppose we left the fast pointer to the intersection point and slow to the head of the array. Now we'll move slow and fast one step until their value becomes the same. So at the starting, the slow pointer points to the value 1 and the fast pointer points to the value 1. So they both point to the same value. We'll return the value as 1. Is it clear? Is it clear? Let me write the pseudocode for it. Okay, analyzing the test case, I will write the pseudocode for it. This starting At the starting, we do not actually form the linked list representation. It is a method to explain the question. Okay, we don't actually make the linked list representation. We just depict our array into the linked list representation and find the cycle in it. If we have found the cycle using the slow and the fast pointer, we make one of the pointer points to the starting of the linked list representation that will form using let me show you how we do using the code. Okay, so at the starting we have a slow pointer and it would be at the index 0. Okay, so fast pointer would be at the index 0. Is it clear? Yes, it is, because at the starting the zeroth node will be 1. Okay, now what we'll do, we'll make the slow pointer move by one step. Okay, slow pointer by one step and the fast pointer by two step. Okay, slow by one step, fast by two step. So what we'll do we'll use a do while loop. You can also use a while loop, but I preferred using it using do while loop. We'll make a slow pointer as a of slow. The value that is present at this will act as an index for the next value. That means you have a node formed using this index, that is 2. Is it clear? We have the fast pointer point to a of fast, okay, and the value which we have got using this, because we have to make it jump by two step now, so we'll make it jump by one step using this, and we further make it jump. Okay, so how would this be explained? We have our fast at this one, we'll make it jump to a of fast. A of fast means a of 1, that means fast would be here. Next, a of 2 would be 3, so the next node in this would be 3, because if we draw the linked list representation of this, it would be 1 and it would be this. Okay, so after one step fast would be here, and two step the fast would be here. Okay, and we do it until slow and fast become equal. Simple. We do it until slow and fast become equal. Let me do a dry run over this code. At the starting, slow would be here, fast would be here. As simple. Slow would be here, fast would be here. At the first node, we'll make the slow pointer move by one step. We'll make the fast pointer move by two step, 1 and 2. And we do it until there exists a point where the slow and the fast pointer meet. Okay, then if they meet, that means the cycle is present, that means the duplicate element is present. Now if the duplicate is present, that means we have to make one of the pointer. Let us make the fast pointer points to a of 0, that means the first node of the linked list representation, and until the value at the slow the value at the slow and the value at the fast pointer become equal. What we'll do, slow we'll make slow move by one step, and we'll make fast move by one step. Is it clear? Okay, when they become equal, we'll return either of them. We'll return either slow or either fast. Is it clear? Okay, so this loop is try to find a cycle if it is present in the linked list. Okay, and this is used to find a value. Okay, that is repeating, that is the duplicate element. Okay, and at the end we'll return the answer. So this is the question to find a duplicate in the array. And this approach requires a time complexity of order of n. And look at the code. Are we using any auxiliary space? No, we are not using any auxiliary space. So it requires a time complexity of order of 1. That means a constant time complexity. So if you have the knowledge of Floyd's algorithm, Floyd cycle detection algorithm that is used in the linked list, you have got this question in one go. If you haven't got this question till now, so I would recommend you to first go through the Floyd cycle detection algorithm in the linked list, and you will definitely get the solution. Okay, so that it's from my side. Bye.